Alright, so that my pause. We were working on C. What is the projected population for Ontario in 2031? So how do we calculate that? Using the relation we were given. So there's P equals 11 million times 1.0112 to the power of 35. Okay, so how do we do that in calculation? So you're not scared by these numbers, you just plug in numbers. So you have to do the first part. 1.0112. Type in the base, then find a button like this, y to the power of x. You hit that, you type in your power, 35. Now it's equal. There's the number, and it matches what we have over here. So then you have to multiply that number on the right to 11 million. So we're doing, remember, we're following bed mass. So times 11, 1, 2, 3, 4, 5, 6 zeros after that, that's 11 million. Hit the equal sign. 16,243,881.7 or 882. Does that turn the same number? Yep. And there it is. Don't forget to write the sentence, and that's your answer. That's the kind of question that I'm mostly worried about. Example 3, compare linear, quadratic, and exponential relations. Let's go through this fairly quickly. So what does in a table of values, what does a linear, reminder, how you know it's linear, quadratic, or exponential? Y equals 2x. You notice that the first differences are all the same. It's constantly the same number, in this case 2. And remember, first differences are successive y values, subtract them. So basically, take the negative 6, subtract it from the previous y value, negative 8, you get 2. Negative 4 minus 6, you get positive 2. And so on and so forth, it's always 2. So you know it's a linear relation when the first differences are the same. And you can see, just to show as a contrast, the ratio of successive y values, so you take negative 6 divided by negative 8, you get 3/4. And you never get the same number. You move on to y equals x squared, so a quadratic relation. The first differences are not the same, as you notice, in the third column. Negative 7, negative 5, negative 3, so on and so forth. But when you do second differences, find the differences between the first differences. So you do negative 5 minus 7, positive 2. Negative 3 minus 5, positive 2. Minus 1 minus 3, positive 2. So on. They're all 2's. They're all the same. Therefore, you know that if the second differences are all the same, it's a quadratic relation. Last, what if the x is in the power? So y equals 2 to the power of x, an exponential relation. First differences, you see, when you do that, there's no pattern. 1/16, 1/8, 1/4, so on and so forth. Second differences, still showing the same problem. 1/16, 1/8, 1/4. There's still, it's actually, the pattern is exactly the same between first and second differences. So it's like, what's going on here? This doesn't work. But we're looking for a pattern that all the numbers are the same. So then we try the ratio of successive y values. So you take 1/8 divided by 1/16 is 2. 1/4 divided by 1/8 is 2. 1/2 divided by 1/4 is 2. Of course, these are ugly numbers. Like, how on earth are you going to do that? Well, maybe focus more on the positive ones, where you got 2 divided by 1, 4 divided by 2, 8 divided by 4, 16 divided by 8. They're all 2. It's a little easier to do that than do these fractions on your calculator. So, though it's possible, I know for most of you it's a pain in the neck. Okay. So you know it's an exponential ratio if the y values, when you divide one y value from the previous y value, and you keep on going through it, is the same number throughout. And there it is on the graph. Straight line for y equals 2x. The red parabola or arc, y equals x squared. And then y equals 2 to the power of x being very horizontal. At the beginning of this graph, as it heads towards 0, it starts moving up and then moves up very quickly once it gets past x equals 0 into the positive numbers. So, in conclusion, there are the key concepts. It's also listed on your handout. That's on page 389. If b is larger than 1, moving left to right, the graph moves very slowly for negative x values and increases more rapidly for positive x values. It's almost horizontal on the left, very steep on the right. It's the b is opposite if b is between 0 and 1. Moving from left to right, the graph decreases very rapidly in negative x values, decreases more slowly for positive x values. Almost horizontal on the right, very steep on the left. The y-intercept is always 1. There is no x-intercept because it never crosses the x-axis. And the growth factor, which is this graph, or the decay factor, which is this graph, the base is the base of the power b. What questions should you do? Number 1. Number 2. It says number 3. Skip number 3 because they're asking them to sketch your graph and graphing calculator. Most of you don't have a graphing calculator. But then I really want you guys to focus on 6 to 13, especially the first 2 questions there, number 6 and number 7. There's very similar questions about population and just the same setup. There's a population question just like the one in the example. And this one is about sound pressure to the number of seconds is your x now. There's another population question for 8. And try to do number 9 and 10. Hopefully this will work out. I don't know how well it's going to work out overall, but let's see what happens. Alright, I will see you on Friday.